Hello, I'm Dr. Kuzma Strelnikov, and in this video, I would like to share some of my reflections about the modern views on brain functions, how we perceive information, and how it is analyzed by our brain. Philosophers and scientists have been posing questions for many centuries about how we perceive information, how we treat this information, and in general, what the relation is between the external world and our inner world. About 4 centuries ago, it was quite popular to compare the brain with a mechanical clock, but this analogy, of course, was far from perfect. It only existed because the mechanical clock was the most complicated device known at that time. Sometime later, there were some other analogies, like the brain as a calculator, a mechanical calculator, an electric calculator, and then later an electronic one. And more recently, the brain was compared with a computer. Of course, these are just analogies, which are very far from what we know about the brain. In the early 20th century, the Pavlovian conception of brain mechanisms was quite popular. This was a simple point of view. We receive some information through our sensory organs, then our brain analyzes this information, and on the basis of these results, we produce action. In other words, we react to the stimulation received by sensory organs. But this conception was also rather simplistic. And about 20 years ago, a novel paradigm of brain function emerged, which was called predictive coding, or predictive brain. In this conception, the brain was considered as a predictive engine, which generates anticipations, predictions about our environment, and the possible states of the environment, possible events in the environment, given optimal or adequate predictions about the environment, about different possible events in this environment. We obtain the optimal adaptation to this environment. So, this conception of predictive coding explains our adaptive strategy, the adaptive strategy of the brain, and it also explains several other aspects of brain function, which are discussed later. In practice, what does it mean to have a predictive coding? For example, even before we go outside into the street, we know what the street is like. We know that there is a central part for the cars. We know that there are sidewalks for the pedestrians. There are buildings along the street. Buildings have a certain shape. People in the street usually wear clothes according to the season. Cars usually have four wheels. They have a certain shape as well. Plenty of things that we can predict. If one day we go out into the street and we see that, for example, cars are upside down, people are naked in winter, things like this, of course, it will be something that violates our predictions. And in this situation, we need a rather profound analysis of the situation. Why has it happened? What's the matter? Why cars upside down, people are naked, and so on? And this analysis, of course, is related to a certain stress because we face an unusual and unexpected situation. This is a deviation from our predictive model, how the street should be. Of course, if we want to explore something new, we go to some places where we know that things are not as usual, then it is quite normal to observe violations of our usual predictions. But in the usual situation, each violation causes a stress. It is actually a sign of a possible danger. We need to think how to react to this situation. Similarly, when we enter a building, there are plenty of things that we can predict. There are corridors, there are rooms. In rooms, there are windows. We know different types of furniture, which is possible to find in rooms. Plenty of things we can predict about the organization of space inside the building, about the organization of furniture, types of furniture, and so on. If one day we enter a building and we see no corridors, for example, this could be strange. One can imagine plenty of factors which violate our predictions, and each of these factors requires supplementary analysis by the brain. And here is an important aspect. If we are surprised by something unusual, which violates our prediction, then our brain starts analyzing it. And we see that in this situation, we need more energy for our brain. Our brain consumes about 20% of energy. Energy consumption is really enormous. And in highly demanding situations, its energy consumption can be even 50% of the whole body. So the brain needs to spare energy. This is why it is important to maintain the best possible predictions of the environment, not to analyze every second what happens. I developed this conception of the relation between surprise and brain energy in several articles. And if our energy is spared, we feel quite comfortable. But if we need to analyze the novel situation, the unexpected situation, then it is a stress. It is uncomfortable. So there are several aspects concerning our prediction and the deviations from our predictions. The adaptive aspect, the subjective feeling, the energy needed for the brain, all this is in the conception of predictive brain, predictive coding. So, this is quite an outstanding conception of brain functioning, and I think that it will be further developed in the future.